Okay, today we're going to talk about geometric series. So if you have not already seen the video on geometric sequence, or if you're still struggling with geometric sequences, make sure you go back and look at geometric sequences because we're going to build upon that today. It's going to be very similar to our video on arithmetic sequences, so if you have watched that one, then this should be rather simple, but we got a couple things that are different that we have to cover. The big difference is, remember that geometric is for multiply patterns, as arithmetic was for addition patterns. So I could derive the formula for right you. What you need to know is that a geometric series is going to be any series that's multiplied, so you'll have your first term, and then you're going to have a second term, but remember that second term is the first term times r. And then we're going to keep doing this, so I'll have r multiplied twice, and we're going to do that all the way until you get your last term, which is going to be r to the n minus 1, because we always end with n minus 1. Okay, so this is our geometric series. There are several different ways to derive a formula for you. I'm going to attach a separate video that shows you one way, but you can Google this. Just look up geometric series derivation, and if you're interested, you can see the different ways to derive it. But the formula that you're going to get up when you derive from this into a simpler formula, because this is pretty nasty, that can be long, and if you have like 100 terms, you don't want to add up all 100 terms. But what ends up happening is you get this formula. S sub n, remember that's our summation, is going to be the first term, and then you get 1 minus the ratio to n, and we're going to divide that by 1 minus the ratio. Okay, so this is a formula that gets derived from all this mess. And it's interesting to note that unlike the arithmetic series, you don't need to know a sub n. You need to know a sub 1, you need to know the ratio, and you need to know the number of terms that are in your pattern, but you don't actually need to know the last number. So it's a little bit simpler in the fact that you don't have to figure out what a sub n is first. But we're going to go ahead and do some practice problems with it. So let's say that we have a pattern of, well, let's go with 1, 2, 4, 8, 16. Very simple pattern, just multiplying by 2 each time. So the first thing you have to do is identify a sub 1. Well, that's our first number. In this case, it's number 1. Next thing you need to know is you need the ratio. Ratio is defined as any number divided by the previous number. In this case, it's the number 2. That's the number we multiplied every time. And we need to have an n. Let's say that we want to know the sum of the first 100 numbers. So we're going to make n 100. Okay, we're actually going to add up the first 100 numbers in this pattern. So n is 100. And now I go ahead and plug it in here. So S sub n, which is the addition of all of our numbers. By the way, if this was a shorter one, like 1, 2, 3, 4, just the first 5 numbers, you could just add them up. There's nothing stopping you from just adding up the numbers that you have. The problem with 100 is there's 100 numbers, so you'd have to write up all 100 numbers and then add them up, and that becomes a little bit cumbersome. But if you have a short set, by all means, just add them up. So anyways, back to here. So we need our first term. Our first term we just decided was the number 1. It's always a 1 minus. We need our ratio, which we decided was 2. Raised to the n power, we're looking for the first 100 terms, so ratio is, or the n is 100. And on the bottom we have 1 minus our ratio, and our ratio hasn't changed since before. It's still the number 2. Now, this is all arithmetic, but we can clean it up quite a bit. And there's nothing wrong with plugging this to calculator right now. Keep in mind when you have things on the bottom more than one that you need parentheses around it. As a matter of fact, it's generally a good idea to put parentheses around the whole thing in the top if you're not 100% sure that it's not going to already do that. But I'm going to show you how to do it by hand just in case. 1 times anything is that thing, so we can ignore this 1. On the bottom I got 1 minus 2, so the bottom is easy, it's negative 1. And then I have 1 minus 2 to the 100. Okay, this negative 1 is just going to put a negative up in the top, so it's going to end up changing it to negative 1 plus 2 to the 100. And 2 to the 100, this is not 2 times 100, so it's not 200. It's 100 2's all multiplied together. So you're going to need to calculate here. Figure out what 2 to the 100 is, and then subtract 1 from it, and that will be your answer. Okay, so this is calculator work at this point. Or, of course, you could plug it in right here if you're really careful. So that's the sum of the first 100 terms of geometric series. Just like with arithmetic, we have some notation. And the notation, of course, is the sigma notation. And they typically look like this. I'll keep using I because I like I. Here's our first 100 terms. And we're going to start with, we'll use the same one. So let's go with 2 to the, well, I guess that's supposed to be an I. I can't. I'm having trouble making that into an I. There we go. Okay, and what you should notice is this pattern looks a lot like our a sub n pattern. And it's so much like the pattern that you can actually read stuff right off of it. So notice that there's not a number right here where this a sub 1 is. If you don't see it, it's the number 1, because when I go 1 times anything, that's still there. Okay, if it's anything other than 1, it has to be written right here. I'm going to go ahead and leave it there so we can see it, but we can now read it right off this pattern. The number out front is either 1 if it's not there, or whatever it is going to be a sub 1. The base, which is the thing that is getting put to an exponent, this is our base, is going to be r. And that only works when this is something minus 1, whatever your variable happens to be. It has to match this pattern, n minus 1. And then this is a sub 1, this is r. And then n comes from right here, provided that this is 1. If it's 1, this is n. If not, n is top minus bottom plus 1. But often we'll have the bottom be a 1, so this is n. And if you remember over here, that's all we needed to know. So we could plug in those numbers right now here into the pattern. I already did it here for you, but you can go ahead and plug them in. So I'm going to leave that up there for you. And the other thing is, just like we talked about before, it doesn't matter what's over here. You need to be able to solve for any variable. So I could give you s sub n, and then you need to go back and solve for maybe a sub 1 or r or n. But you need to be able to go any direction. So I'm going to let you do some practice problems. If you have any questions, please make sure you ask me. But this is Geometric Series.